Okay, so back to this problem. Um, okay, so earlier or let's see, no, okay. Um, so here's the modified quotas, because now it's still 4,700, but they're dividing by the 1050. It's still 3,700 divided by 1050. It's still 1,600 divided by 1050. And you can see that the modified quota, we now got 4.48. And again, Jefferson rounds to the lower quota. The round modified quota down. He goes down. So he goes to the 4. 3.52, he goes 3. 1.52, he goes 1. That only adds up to 8. It's still too small. So we're going to have to modify it again. Remember, you're trying to get one of these numbers to become bigger. So what you're dividing by has to get smaller. Okay, so what did they try next? Next they tried 935. And again, these are just random numbers. They're just pulling them out of their ass, you know. There's no there's no methodology to this. Just like, let's try this lower. And sometimes you go too low and you're like, damn it, I gotta come back up again. So it is kind of a pain in the butt, but you know, it's another method. So now Jefferson tries 935. So you can see he's dividing by 935 now. And there we go. That one came up. It was a 4 before. So there's your 5. This one's still at 3. But remember, his quota, he goes to the lower quota always. So even though 3.96 is really close to 4, he just still grabs the 3. He always goes with the lower quota. And 5 and 3 and 1 does add up to 9. And that's what Jefferson did. Okay, now, when you go to atoms, it's the exact same thing. Use trial and error to find a modified divisor that is larger than the standard divisor for the apportionment. He now is going to go up. Atoms goes up. I think I said this earlier. I was telling you that Jefferson, it looks like a J, right? Because he goes down. Well, when you're looking at atoms, let me go with green for atoms. When you write the letter A looks like an arrow pointing upward. So he always uses the upward one. And then when you get to, I don't know what color I'll use later, but we'll do orange for now. When you do Webster looks like a W. Webster is down and up and down and up. He just changes. It depends. Sometimes he's down, sometimes he's up. He uses the standard rounding rules. So the letters of their names kind of helped me remember this. Jefferson, you draw J down and then it curves, right? So down and curves. And A looks like I'm pointing upward, so he's going to use the upper quota. And then, of course, Webster, W, he's down and up and down and up and down and up and down and up. So, anyway. Okay, April. Enough of that. So, when you're looking at atoms, he is going to use trial and error to find a modified divisor that is larger than the standard divisor for the apportionment. Calculate the modified quota for each state and round up. Round up. He just rounds up. It's the exact same methodology. So here's the same thing again. The same 3 companies, right? They still add up to 10,000. 10,000 divided by 9 is 1,111.11. When, let's see, this means, So earlier when we did it, way back when, remember it only added up to, I think it added up to more. Let me slide back to that slide. Let me find it. Give me a second. Was it here? Yes, it was here. Okay, so if we were doing atoms at this point, when you divided by the that 1,111, Adams would look at this 4.23 and he'd go, I'm going to give them 5. He would give them the upper quota. He'd round up to the upper level. 3.33, he's like, that's 4. And 1.44, that's 2. But that adds up to 11. That's too much. It's only supposed to add up to 9. So he needs one of these numbers to get lower, which means what he's dividing by has to get bigger. Where was that picture where I drew it before with the 12s and the 6s, and I lost it. Oh, here it is. Remember? Now we're doing, he needs one of these numbers to get smaller. So that means what he's dividing by has to get bigger. And if you think about it, he's going to round up. It needs to go up. What he's dividing by has to go up so that the numbers get smaller. Okay, what slide was I on? Oh, no, wait. Oh. Where was I? I was there. Yeah, here's Adam. Okay. All right, so blah, 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 blah. There's that number. So here's a new table. And so instead of 1,111.11, he's like, you know what? Let's just try a nice, cool 1,200. And once again, just picking a number that's bigger than that 1,000 number. So into 1,200. And when he divided, he got 3.92, so he gives them 4. 3.08, he'll go up to 4. 1.3, he'll go up to 2. That adds up to 10, which is too large. So this number has to get even bigger. So he tries again with a bigger number. He goes to 1,250, and he gets 3.76. He would give the upper quota, which is 4. 2.96, the upper quota is 3. 1.28, the upper quota is 2. And now it adds up to 9. And boom, he did it. He's cool.